Welcome to Part 2 in the module on Patterns and Frameworks for Service Configuration and Activation. In the previous part of this module, we had talked about the Component Configurator pattern. Now, we're going to describe how ACE implements this pattern as part of the ACE Service Configurator framework. Naturally, there are other ways to implement this pattern. We'll be focusing on the way in which we do it in ACE. So let's motivate the need and the way in which this framework is going to act to begin with. Capturing and managing the life cycles of services involve a number of different aspects. It involves dealing with initialization aspects. It involves dealing with aspects having to do with execution control, running event loops, suspending, resuming services under various conditions, and so on. And of course, it also deals with termination or finalization, shutting things down when they're no longer needed. If you implement these things in a very ad hoc way, you can end up with solutions that are tightly coupled, difficult to evolve, and difficult to maintain over time, because each service will be done in a slightly different way, and it'll be hard to control them in a uniform and centralized manner. So to avoid this, we have developed a framework called the ACE Service Configurator framework. And the classes in this framework allow applications to defer certain configuration and implementation decisions about the services that they provide until late in their life cycle, late in their design, namely at installation time or even during runtime. Applications or services that use this particular framework inherit from a base class called the ACE Service Object, and then they override some of its methods, and the ACE Service Configurator framework then invokes these methods in order to configure and control the life cycle of the apps and services using the framework. We'll talk about a number of these different classes in a moment. Of course, these classes correspond closely to the roles and responsibilities defined in the Component Configurator pattern. Here's a brief summary of the key classes that are part of the ACE Service Configurator framework. One of the core classes is called ACE Service Object, which is this base class that provides a number of hook methods. These hook methods are used to control various lifecycle activities of a service or a component while it's being brought into existence, while it's being executed, and when it's being finalized and shut down. There's also another class called the ACE Service Repository, and this is used to store instances of ACE Service Objects. Because we're going to be able to configure the application and its services dynamically, we need to have a common place to go to learn what services are actually provided at any given point in time. And so the service repository is used to keep track of that kind of information. Then finally, we have another class called the ACE Service Config. And this class is essentially an orchestrator or a facade that's used to provide an interpreter that reads a scripting language that can be used to dictate what services are configured or unconfigured, suspended, resumed, and so on. You can take a look at this URL for more information about the ACE Service Configurator framework, which also, of course, appears in some of the books on ACE as well. So let's talk a bit about the ACE Service Object class. This is a base class that the framework uses to invoke various kinds of hook methods to control the life cycle of the services. And here are some of the different types of lifecycle methods it supports. It has a pair of methods for being able to initialize and finalize or terminate or shut down a service object that's under the control of the framework. It also provides hook methods for being able to suspend and resume a service. There could be certain situations where you don't want the service to be active. Perhaps you're updating some of the data it uses, or you're changing its implementation for some reason. And so you can suspend it temporarily so events are not dispatched to it. And after you're done, you can then go ahead and resume it so it can continue to process requests that it's getting from wherever its clients come from. Yet another capability provided by the ACE Service Object is a way to report information about the dynamically configured service. You might say what its purpose is as a string. You might contain its current status, its load, whether it's active or inactive, the port numbers or other addressing information needed for clients to be able to connect to it, and so on and so forth. By inheriting from the ACE Event Handler, ACE Service Object is also capable of being dispatched by the ACE reactor framework. So these frameworks work together to provide you with a number of capabilities. From a commonality and variability point of view, the ACE Service Object class allows us to handle the variability of lifecycle operations within a common interface. So we have these hook methods that may differ, but they're all managed in a common way, a common uniform interface. Let's now talk about the ACE Service Config class. This is a class that basically provides a facade. It hides all the complexity of the internal details of the framework, and it's used to integrate and provide certain capabilities. One of the capabilities it provides is it provides a way to interpret a scripting language that provides various directives that can be used to do certain side effects to the state of your application process. One thing you can do is you can indicate how to locate and initialize service implementations during runtime. You can also tell it to suspend and resume these various kinds of operations as well. It's also possible to be able to use this class to trigger reconfigurations of the services dynamically. And we'll look at some examples a little bit later that illustrate this in the context of our web server. There's a couple of different types of services that are provided by the Service Configurator framework and the ACE Service Config class. The most common kind are the dynamic services. These are services whose implementations can exist in DLLs or shared libraries that are linked in to the address space dynamically as the process is running. It's also possible to support certain kinds of statically configured services. These are services that are actually linked with the initial executable, but whose existence can come and go based on directives that are interpreted by our scripting language. Once again, from a commonality and variability point of view, this particular class handles the variability of static and dynamic service configuration within a common set of interfaces. Let's take a look at some of the directives that are provided by this framework. These directives are essentially commands that can be passed to the Service Configurator framework in various ways to dictate or designate the way in which it behaves. Here's a particular example that illustrates a scripting file that shows how to instruct the Service Configurator framework to dynamically link in a particular DLL, extract out a factory function that can be used to make an instance of an HTTP server, and then go ahead and initialize this, listening on a certain port number, and if all goes well, to register the resulting configured object that was dynamically linked into the service repository so it can be manipulated and accessed at runtime. ACE Service Configurator Framework supports a number of different types of directives. It supports dynamic linking directives, static initialization directives. It supports a directive for removing something that was either linked statically or dynamically to shut it down. It supports directives for suspending and resuming services, and it also makes it possible to dynamically configure certain hierarchically composed services. We won't talk much about that at all in this example, but it's yet a further way of being able to integrate dynamic composition with other capabilities that ACE provides in terms of layered service composition. We're going to focus primarily on the dynamic, static, and remove directives as we illustrate some of the examples we'll talk about later on. There's two primary ways that you can tell the Service Configurator framework to process directives. One way is to give it a file named by default as svcconf or serviceconf. This file contains a set of directives that illustrate what needs to be done, and we'll look at some examples in more detail in just a moment. You can also create strings from whatever source you want, from some kind of editor. You could pass them over a network or whatnot, and then be able to pass these things as processing directives to the ACE Service Config object in one fell swoop. And that way you can have even more fine-grained control over how you manage configuration and reconfiguration. So to summarize this particular section, the ACE Service Configurator framework improves the extensibility of servers like JAWS by deferring the implementations of some of their components and objects or services until late in the design cycle, when they have enough information to make an informed design choice. These late binding capabilities provide a number of benefits to application developers. One of these benefits is that the apps themselves are composed out of very modular services that can be developed independently and tested independently, and then brought together and integrated into a complete solution at the appropriate time, when you have the right information to make the right choice. This also allows, this decomposition capability allows developers to focus on things in isolation. They can focus on the functionality. They can focus on the optimization without prematurely committing themselves to a particular assembly of the different services, which gives you more control over how your systems will evolve over time because they're built in more decomposable ways. And then the last capability we get from this late binding is the ability to change our mind at installation time or runtime when we have the information we need. As we go through the next part, we'll discuss some examples and illustrate how this framework can be applied more specifically to extend and enhance the JAWS web server.